Yeah. You're not really quick, but also.
I got there for
Yes, it's wrong. Is it wrong?
This one, what I was just before was more.
Automatic configuration. So I went to those now, just I keep saying, oh, you have to change this. Walk over that. Computer get locked out. They pushed out permissions. For each admin to approve it. Well, you push those out, and everybody on the new DNS. Well, I couldn't verify with the system, so I'm going to share that in. It's like, it doesn't have access to the domain. Yeah, I got paid overtime for it, so. Which that one's like $2,500.
Yeah, so when I went on Friday, they were talking about that.
Yeah, I have this people come with. That's right. Having like the online events. You guys ready? Maybe? All right, we've been pushing really hard. Today's lecture hopefully be a little bit of a breath of fresh air. We're gonna slow down just a little bit. I don't have to do like 80 slides today, which will be good, which will allow us to get our lab done and then also finishing up our code assignment, right? Because everyone started it, you're all pretty close to done. We just need to put the last touches on it.
And
Right?
totally.
Totally. Because it's due on Thursday, right? Second one's already up there, although I'm not going to talk about it until this one's ready. The second one's already up there. Okay, go on. Any more questions? No one's asked, like, when you get like grades into this class? No.
We're just hoping that you never grade.
That's right. If I never grade, everyone's going to pass, right? At the end, I won't have time to grade everything. I'm like, all right, fine, good enough. You turn it in. That's an A. I mean, you should. I haven't graded anything, and I'm going to get on that, but you should at least know if you've been turning stuff in and it's been passing your test. You probably have a good idea of whether or not you're doing good or not.
It's harder to forget to write my name.
I think you might lose like a couple points. The more you forget your name, the snarkier the comments get. I'll start filling in names for you. It is, on the commit message, your name's on there, so there's a little bit of stuff. But it's so important to say this is me and I did the work as opposed to someone else. Morning. How was the ride in the rain?
Cold.
Yeah. All right. So we're gonna talk about all this. Nice thing is, they're not that hard, and then we're gonna talk about like the magic that happens when you type make or when you do G++, and we'll talk about that kind of stuff as well. And we'll talk about something big, function documentation, right? Which is part of what assignment 1 is about too, is writing the documentation for your functions. We'll talk about all those, and it'll be good. Let's talk a little bit about scope, and scope's the idea of where you can use a variable. So basically where you declare a variable kind of defines where you can use it. Because now we're trying to write code in main, code in other functions, and so where do those variables exist? Where can I use them? And that's really all about what scope is. So here I have a function called total cost, right? I have 2 parameters and another variable, right, inside the function. Right? Why are not all 3 of the variables parameters? Why is subtotal not a parameter? What do we infer from that?
Because you want it to be in the function?
So I want it to be in the function. And what are parameters for? Right? They're variables, but what are they for?
Input.
Input, right? And so I'm saying that num-param and price-param, those are input variables. But subtotal has nothing to do with input, right? It's not going to take values in. It might do something with those values, right? Store it. But it's not for input. So we don't put it up in the parentheses because we don't need it for input. We just need it in our function. Are we good with that distinction between the two? So num param, price param, subtotal, three variables, they exist only in the function total cost. I can name them anything so long as I follow right naming rules. But overall, right, these three variables exist in total cost. They only exist in total cost. They don't exist anywhere else in my program. So we say num param scope and really price param and subtotal scope is the function that it was declared. And that kind of scope is called local scope. And we say they're local to the function that they were created in. So local to the function they were created in. Right? Subtotal, local variable. Local to the function. Right? And so what this means is that I might have stuff going on in main. Right? And in this case, I'll have stuff going on in total cost. Right? And total cost has num param. Right? Price param. Right, and it has subtotal, right? These variables exist only in total cost. They don't exist in main. Okay, in main I might have a variable called x because that's a great name for a variable we know, right? I could also have a variable in main called subtotal. Okay, but that subtotal is what? Different from total cost subtotal, right? They're in their own scope. They can have the same name, but they're different variables because they're separated by which function they were declared. And we go with that, right? You can also create variables that aren't local, but they are global, meaning they exist in all functions and really anywhere in our program. Okay, we don't do that for regular variables, but we can do it for constants, so values that don't change. We can say, right, I want to define these things as constants. I want to use them everywhere. I mean, I don't want to really pass them into functions. I just want them available to me. And so we can do that as well, right? We create them before our function declarations, after our includes and our uses and that kind of stuff. All right? So after the includes, after the use statements, right? And you just write to create a constant global, right? You would just say const because it's a constant, and then whatever it is, double pi equals 3.1415, right? And then you can use that in the rest of your program. So you don't have to recreate it in main, you don't have to recreate it in any function that you do, it just exists, right? And we won't change it, right? Because it's what?
Constant.
Good, right? It's constant. Let's talk about blocks of code real quick. So blocks of codes are curly brace code, right? All functions are blocks of code, right? Int main, open curly brace, close curly brace, right? And what you declare in that block of code is really a variable that exists in that block of code, right? So that's why I would say variables are local to the function they get created in because they get created in a block of code, which is that function's code. Does that make sense? Right? But really, technically, variables have the scope of the block that they were created in. Okay, variables have the scope of the block they were created in. Sometimes we have blocks inside of other blocks. So sometimes we have curly braces, right? And then we have more curly braces. And then we might have more curly braces. And that looks really weird until you do things like what? Int main, right? While something, and then if something. And we do that. So really, we nest blocks of code all the time. We just don't do it without something else with it. And what we're saying is that if you create a variable inside of this block of code, it only exists where?
In that block.
In that block of code. So it only exists in the if statement. Okay? It also supersedes any variable created in this block of code. Which supersedes any variable that's created in that block of code. Okay? You notice that all those variables have the same what?
Name.
Name. But they are distinct variables themselves because they're each created in their own block of code. Do we do this?
No.
No, right? That's why we try to teach you, like, just create all your variables at the beginning of your function, right? And then use them. Right? We don't want to be creating variables in weird spots because what happens is, once you create it in here, right, and if we didn't create it in here, it only exists in the if statement, it does not exist in the loop, okay? Inside blocks can always look to the outside for a variable name. But outside blocks can never look inside to see if there's a variable in there. And they kind of look inside where they are, they want to look to the outside. So I think I have a picture, so that's what I want to go to. Right, so something like this. So how many variables do I have? 2, right? This is not a trick question, 2 variables. Right? Will this code compile? Right, if it was inside main, would it compile? Yeah. Did you know that you can just put curly braces wherever you want in C++ and it doesn't care? It doesn't have to be part of an if, it doesn't have to be part of a while. Right? Should you do that?
No.
No. Right? But I get people's code like this because they just accidentally hit the curly brace key or they're trying to close curly braces and they just add a bunch. Until it what? Just add until it compiles, right? That's all you need to do, right? It passes the unit test, it's all good. Right?
It's not
Is that,
not good
Is
test.
that not what we do?
No.
Sometimes we can admit to it, maybe. Right? But really, we should know where my curly braces are and what they do, right? But technically, this code would compile. Right? And so I'm going to call this my inside block, and I'm going to call that my outside block. Okay, so imagine I'm inside of main or something like that. Right? This variable exists inside of this outside block. This variable exists inside of this inside block. Now, code goes from what? Top to bottom, right? So at different places in the code, if I tried to, let's say, see out X, right, different things are going to happen depending on where I am in this code. That's what that says. Okay, so let's say that I'm right here. If I try to see out X, or sorry, not X, if I try to see out number right here, what would happen? No, not garbage. What? Who knows?
It's not declared yet, right?
It's not declared yet, so what am I going to get? Compiler error, right? If you try to use a variable before it's declared, you get a compiler that says what? Number was not declared. What does it say?
In this scope.
In this scope. What are we talking about right now? Scope, right? Told you the compiler errors might start making sense this semester. Maybe not, but they should, right? So right here, we try to see out number and I get what? Right? No, above it. Nothing. Compiler error. Right? Then I create number, and so right below it, inside of the outside block, if I see out number, what do I get?
1.
You get 1. Woo! Right? Nice and great. Now I go inside the inner block, but let's say I'm above this declaration, right? I'm above the declaration inside the inner block. I see out number, what do I get? I still get 1. Because inside blocks can always look to the what? Outside. So it says, right, it's going to look up and to the outside and says, is there a number that exists? And is there a number that exists?
Yes.
Yes. What's its value? 1. Okay. Now, on the inside block, right here, if I see out number, what do I get? 2. Always going to look up and to the outside. And it looks up and it says, oh yeah, I got a number. It's 2. Now I'm going to leave my inside block, so I'm going to be right here in between the 2 curly braces. If I see out number, what am I going to get? 1, because you can only look to the outside and never to the inside. So that inside number is gone, right? Just imagine that code doesn't exist, right? Right here, I can't look inside the curly braces, but I can look up. And is there a variable called number? Yes, there is, and its value is? 1. It always looks up and to the outside, right? If it doesn't find it in your block of code, the only other place it can look is inside a global scope, right? Is there a variable created globally that I can use? So it always looks in your scope and then up into the outside, all the way to global scope. And if it doesn't find it, that's when you get what? Variable was not declared in this scope. Does that make sense? So did you do this? Probably not, right? You should probably just create a variable called number and use it, right? You don't need them in separate scopes with the same names, okay? But I'm also trying to impress on you that what? Just because you're in a different scope doesn't mean that they can't have the same name, right? Variables can have the same name so long as they're in what? Different scopes. I think a lot of times as students when we learn like arguments and parameters, we get really scared of like, do they need to be named the same thing, right? Do my arguments that I pass in, right, need to be the same name as the parameters? And the answer is no, right? Because they're in different what? Scopes. So they can be named whatever you want, right? Of course, we name them based on what they do, right? So name them well. But right, your argument shouldn't be called num-param or price param because they're not what? Parameters. Another weird thing, scope, just for us to know, is that when you create a variable in a for loop, which we do all the time, that variable exists only in this for loop block of code. So it only exists in that loop body. Right? So if I say int I, that I only exists in what? This for loop. When the for loop ends, what happens? I goes away. Which is why when we write a bunch of for loops, we always keep saying what? Int I, int I, int I. Right? Create I in your for loop. Right? Initialize it to what you want it to be. Right? Write it for. Questions there? All right, let's look at an example. All right, so here's my lovely scope example with my amazing function called dummy. All right, the function is a void function, meaning it produces no value. Right, it has how many parameters? 1, and the name of that variable is what? 1, which is a good name for a variable or a terrible name for a variable? Terrible, right? Because you're basically saying this variable's value is going to be what? 1. What's the point of having a variable if it's only going to ever have 1 value? Right? So it's a terrible name, but if you learned anything this semester, it's that I name my variables terribly, right? And it's your goal to figure out if I'm doing it on purpose or if I'm just lazy. Could be both, right? Both could be the answer, right? So there's dummy, there's main. All right, where does my program start?
The function declaration?
Right here. Right?
Oh.
Main.
Yeah.
Look, I wrote a comment. See, I'm trying to teach you this semester to read comments because they're important, right? What does the comment say? Program starts here. So where does the program start?
Mm-hmm.
Right below that comment. Maybe let me I'll sprinkle it at other places. Right? Just joking. That's not where we start. Now, in main, right, there's some variables, and some variables actually get created when a function starts. Right? And so let's create those variables, right? There's a variable called 1, whose type actually is double. Right? And its value is what? 1. Technically, it's what? 1.0. Right? Everyone get that that's actually, there's something special that's happening on that line. Because 1 is a double and 1 is at what type? It's an int. So what happens? 1 gets type coerced automatically to be a double. There's so much going on there, and we don't really care, but it's there. Okay, also create a variable called what? 2. This time it's an int, whose value is what? 2. All right, and we'll just say here's my output. I see out local 1 plus local 2, right? And then I do what? 1 plus 2. Well, the value of 1, I only can look in either my function or global scope, right? I always look at my function first. So my function is there a variable called 1? Mm-hmm. Yes, whose value is? 1. And then there's also a variable called what? 2, whose value is? 2. 1 plus 2 is? 3. And so my output is? 3. Everyone good there? Now, line 23 is what we call a function call. Okay? Line 23 is a function call. A function call says, I want to go to this function, right? So I use the name of it. And if that function has parameters, I want to pass in these arguments, right? Some values that I want this function to use. Everyone good with that? Are we talking about functions, what, last class and the class before? So I just want to make sure that we're all on the same page. Find a function named dummy that takes in 1 argument, right? Because it has 1 parameter for a placeholder. How does it find dummy? It looks for that function and it looks for 1 parameter, and it first looks for that parameter of that type. So it's actually looking for a function called dummy that takes in 1 what? What type? Int, because 2 is a integer. And if we look up on line 13, we have a function named dummy. Notice it has to be spelled correctly, right? Capital D. Right? Does it have 1 parameter?
Yes.
Yes. Is it an integer?
Yes.
So it's an exact match, right? I don't have to type curse. I don't have to do anything special. Boom. That's the function I want to do. Now we write those functions, right? The declaration goes above, but then by tradition we write the definition below main, so it's down here. Right? So here's my dummy function. It has one parameter called what? 1, right?
Yes.
It is an int.
Mm-hmm.
Now it starts with the value of the what? The value of the argument, right? My dummy function's parameter starts with the value of the argument. Okay, now the argument passed in was what? 2. So it looks at the value of 2, which is 2. So far, the names work out, right? But that value gets passed into the parameter 1, right? And the value is 2. By value or by reference? By value, right? Because there's no ampersands, right? So I get a copy, right? And this also should help. Remember I said when it gets copied in, whatever you do to it in the function doesn't affect the other parameter, right? Or the other variable. Because this only exists here, right? You have no access to anything in main. And in fact, according to the program, you're not in main anymore, right? You've moved on to a different function with its own context. Make sense so far? Now, in that dummy function, not only does it have a parameter named 1, it also has another integer variable called what? 2. And obviously its value is what? 5. 2 plus 2 is 5, right?
Yes. This isn't a math class.
Yeah. This is a math class. The computer's supposed to do the math for us, right?
Yes.
We just have to tell it what to do. It's a logic class. Did you know programming? That's really what it is. It's all logic. 2 variables, local to what function? Dummy. Okay. So here, when I see out 1 plus 2, I'm only going to look where?
In the function.
Inside a dummy. And obviously 1 plus 2 is
7.
good. All right, you ready for the key thing that happens now? Function ends. Okay. Which means that I am no longer in my function. Where do I go?
Back to main.
Back to main, or back to the call, right? In this example, yes, back to main, but back to wherever that function call was, right? So I was on line 23 in main. I jumped to the dummy function. I did all the code. Function ends. I go back to the call, right? And continue on after line 23. And then the other big thing that happens is that all of this work that I did here,
Gone.
it goes away, right? Which helps us realize that I can't use those variables right now. Right? I can't be in main and use those variables because they don't exist. If I call the dummy function again, it will recreate the variables, right, inside that function. Right? Hopefully this will help us with that whole notion of like why by reference is more efficient. Every time I call the function, it's going to recreate the parameters and any variables in it. If they're large variables, then it's going to take more work than small variables. Does that make sense? We get on scope?
Yes.
Other questions on scope? I didn't put global variables in there. When we get to classes and objects, they have a little bit more scope, but not a lot. So we'll just figure that in as we go. Does this make sense how functions work? How variables work? Why you can use them, where you can use them, why you can't use them, where you can't use them, right? Good advice. In your function at the beginning of it, create any variables that you need to use, right? Of the types that you need them to be. We have compiler warnings on, which we'll talk about today, right? So if you create variables and you don't use them, the compiler will tell you. So create some variables. If you don't need them, the compiler will tell you just delete the variables. Right? But create the variables that you think you're going to need for that function. Other questions? We talked, right, about like character functions and string functions, some functions that are kind of built in for us. I'm just going to give you some more in case these would be helpful. They might not.
Fabs.
Right, fabs. Right, I love fabs. Square root, pow, abs, and fabs, right? So these are math functions. Get the square root, right? Get the exponent, get the absolute value of integers, and get the absolute value of floating points. Right? And then I give you some examples, right? Square root just takes in one double, returns a double. Pow takes in two doubles, returns a double. Right? Absolute value takes in an integer, returns an integer. Floating point absolute value takes in a double and returns a double. That make sense? You'll notice we include CMath, even though abs is in C standard library, it's also in CMath, so you can just include CMath. Or anytime you need to do a bunch of mathy type stuff, really CMath is the include that you should use. Some other things, ceiling, which rounds up regardless of the number, right? You'll notice that it takes in a double and it returns a double. Okay, so ceiling rounds up, doubles. Floor rounds down, doubles. Okay, do you need to round integers? No, right? There's no point. Right? It doesn't work. Exit, the function you should never use.
Ends the
Right?
program.
Ends the program. Okay. Normally, where does our program end?
Return 0.
Return 0 inside of main, right? Exit will crash your program anywhere. And I say crash because that's really what it does. It ends your program wherever you are. You should always write your code so it always gets back to main and gets you out of there. Okay? You shouldn't write code where you get stuck somewhere and you're like, oh, I need to be done now. So I'm just going to type exit. I'm done. Game over, right? It should go back through main and exit gracefully. But exit will kill your program. Rand and srand are the ways to get really non-random numbers from C++. Right? If you're writing a program and it's really dependent on random numbers, I would do some research because using rand is not your best bet. They're pseudo-random numbers. And then the seed for rand basically says, in the pseudo-random number generator, what number are you going to start with? And the seed will always give you the same set of random numbers. Okay? So we could just say that seed 1 always gives you 2, then 5, then 7, then 9. Okay? If you do seed 3, you'll get a different set of random numbers. But if you do seed 1, you'll get the same set of random numbers again. 2, 5, 3, 5, 7, 1. Does that make sense? Which is useful for testing purposes, because really, right, randomness is good in a program, but for testing purposes, we don't want randomness, we want what?
Precise.
Right, precise. So sometimes setting the seed is nice for it to be the same, for testing only. All right, so those are some functions. You may use them, you may not. You don't need any of them on in your code assignment, so that's good. So now documentation, right? And documentation encompasses everything that we write, right? It's comments, right? It's the header comment in your program, right? And so let's talk a little bit more about what documentation looks like with functions, because it's pretty precise of how I want you to write it. So what kind of comments should you have for your function prototypes or your function declarations, right? The comments that say, hey, here's a function called dummy, this is what it does, okay? So we want information about what the function does, right? The total cost function, right, computes the total cost of, right, the parameters, right, plus tax or something, right? You should also say what the parameters are and do, right, and what the expected return data is, okay? Let's look at this. What's the name of my function?
Function 5.
Function 5. What does it take for input? An integer. What does it return?
Integer.
An integer. Okay, so there's a little bit of documentation just in your declaration. Does that make sense? Just reading this line without reading the comments that you don't read anyway, right? Reading this line tells us function name, what does it take for input, what does it produce? Are we good with that idea? The comments should tell you what the function does, because we can read this, but do I know what that number is? No. Do I know what this integer produced is? No. What tells me that? Right? The comments. Right? Look at the lovely description of my function. This is function 5, and this is where the description of what function 5 does.
Very helpful.
Is that so helpful? Right? Now, in your code assignment, right, this function's name is max, right? It takes values in an array and returns the what? The largest value in the entire array. Look, I just did some of your work for you. Right? No one's paying attention though. So okay. Right? That wasn't that hard though, right? Just describe what the function does, right? From a high level. What does this function do? Then, right, @param, right, describes what each parameter does. So if your function has 5 parameters, how many @params do you have? 5. Right? Easy, right? If it has 1, you do 1. If it has none, guess what? No @param needed. Right? So what is this number? Right? Or in the case of our code assignment, right, @param would be like the integer array, right? This is an integer array, right, that holds a bunch of numbers. Right, that you're trying to find the maximum value of. And then what does it return? In this case, what we care about is the type. It's an int, right? The value that is returned is the largest value in the array. Make sense a little bit? Right? And so you just describe a little bit. You've seen this, right? A lot of the coding assignments I've given, not coding assignments, a lot of the labs I've given you had stuff like this, right? You should be able to read this and be able to create this, or you should be able to look at this and use that to figure out what's going on. Some people have problems with the fact that it's above the function, but it's always above the function, right? Comments for a function are always right above that function. So like in today's lab, I don't write the functions for you, even the declarations. I just give you this green stuff, right? The comments.
Oh.
Right? And you should be able to create the function based on the comments. Good news though is you don't have to write any comments because I wrote them all. Right, so it's a good trade-off.
Next time it's going to be the opposite.
Right? And then really there's only a couple different ways that you can write functions. So I've given you documentation of what all those different ways are. Right? This is the easiest function to write. It is a void function that has no parameters. Right? So it does something, but you can't change what it does. And it doesn't produce a value. Does that make sense?
So what's the point of having it?
I don't know.
It doesn't do
Tom doesn't tell me, so I don't remember.
It doesn't really do anything.
Doesn't really do much, right? You could have like right, something like cout's ASCII art, or there are things to do, but there's not a lot.
Yeah.
Right? Really, these void functions are because you have a bunch of code and you're tired of rewriting it over and over again. But it's just like very set code. You're not changing it, right? The beauty of functions is that we have parameters, and those parameters can then change what that function does. Right? So function 2, still a void function, so it only has one parameter. So we have an @param describing what the parameter is. So void functions, no parameters. Void function with parameters. Void function with multiple parameters, so we just do one for each one, right? A function that returns a value, but no parameters, right? So we have our @return saying it returns an integer, and this is what it does. And then that last example we saw in the slides, where it's a function that returns a value, and it takes in a value, but it can also take in what? Multiple values, right? You can take as many values in. Documentation is important. More so in this class, documentation is important because you don't get points for documentation. You can only lose points for documentation. Should I say that again?
So you can't.
So you don't get points for documentation, right? So like in my class in Algorithms 1, right, 10% of your code assignment was just comments, right? If you wrote comments and your code was crap, you got 10 points, right? 10%. Does that sound great?
Great.
I have students that they're like, their code was amazing. They're like, I'll just take the 10%. Right? I still get an A if I do it right without writing comments. Right? This semester, right, comments aren't part of the point structure to gain. So every function you write will have points associated with it, right? You write all the things, that's great, you get all the points. And then you get negative points for missing documentation. So if that were the 100 points, you might still lose 10 points for documentation, right? But you don't gain 10 points. So it's kind of in your best interest to write documentation. I'll start yelling at you eventually. Questions on documentation? We rocking?
Yeah.
All right, you ready for the new stuff?
No.
Oh, well, too bad. We're going to do it anyways.
Oh.
Remember, a lot of this semester is saying that we lied to you in previous semesters?
Yeah.
Yeah, so today's one of those days, maybe. Right? Because really, when we hit the run button or the make button or type make or hit G++, there's a lot that's going on, and it's not just compiling your code. And so we're going to talk about today what all that is. And after today, you'll be like, I never wanted to know that, or, oh, this is super cool. I'm glad that I know. So look at all this fun stuff that happens when you type make. Okay, and we're going to kind of break it down. But when you type make, a lot happens. A preprocessor runs and does some stuff to your code. Yeah, your code's not your code when it gets compiled, but you're right, it's been mishmashed. Right? Goes into a compiler. Compiler only changes your code from a high-level language like C++ or Go to assembly. Okay, assembly code, remember, is basically, right, binary but with words. Okay, but it's a one-to-one type thing, right? Now, once you get it to assembly, then you need an assembler to change it from assembly to object code. And object code is just a fancy word for binary, right? You'll notice that at that time, the assembler also brings in external libraries, meaning like, hey, make this work for Windows, or make this work for Mac, or make this work for Linux. Right? There's other stuff that has to come in, right? Right? Remember the magic, you type int main, that's where the program starts, but we don't really know how the operating system and the program like work together. Right? So the libraries do that, right? So we assemble, right? We throw it through a link editor to bring everything in, and then that's where you get this standalone executable. Right? The standalone executable is object code, right? Binary that the computer understands and really what the operating system understands. That can just run. Right? Remember, at the end of it, when you have your executable code, you no longer need your what? Your source code, right? You can write your program, you can compile it, right, through all these steps. You get your exe, your executable, and that one you can take anywhere. Right? You don't need your source code. Make sense a little bit? Right? Should we go through what they all are? Yes. Right? That's what you're going to say. Yes. So preprocessor is the first place that your code goes. Okay, so preprocessor is the first place your code goes. Right? It takes your source code inside of it, right? Takes it as input. It's going to do something to it. What does it do? It gets rid of comments. I just talked a long time about you should have comments in your code, and the first thing the preprocessor does is what?
Removes them.
Throws them out. Because the comments aren't for the computer. Right? So the preprocessor takes all your comments and deletes them. Right? That's not what I do. You're like, yeah, it is. You just read over it. No, I read your comments. Right? Sometimes. Right? So all your comments get stripped away because to create an executable, the computer doesn't need comments. Good with that idea? Right? It interprets special preprocessor directives. What the heck does that mean? Anyone want to guess what a preprocessor directive might be? You've been writing them since the first day of class. Right? Anything good that starts with the pound sign is a preprocessor directive.
Oh, that's a hashtag.
It's not a hashtag, not yet. I'm holding out. You're like, no one uses phones anymore, right? It's not.
Yeah.
When you call your bank and they tell you to insert something and hit the what key?
Pound key.
They don't tell you to hit the hashtag.
They're gonna start saying that soon.
You're like, we don't call banks, we just do it on the app.
No, we just rob banks.
What the heck?
Or go to the ATM.
Yeah, right? Just stick it in and call it. All right, anyways. Right, so they're pound signs. So includes, right? Because what does an include? An include says there's other stuff, right? And an include is actually just a placeholder that the preprocessor is going to copy and paste the code from that file into your code, okay? You only really compile one file, and so it's the preprocessor's job to pull in all your other files together and make one Uber file. Although it gets shorter because your comments go away, right? No, it doesn't. There's another one called pound define. We're going to get there when we do classes and objects. But pound define allows you actually to create variables for the preprocessor. So not only do we write C++ code, but anything with a hashtag, and see, there you go. Anything with a pound sign, right, is going to define something that gets replaced at preprocessor time. So it's actually preprocessor variables, which could be cool or could not. C, not C++, but C does this a lot. C uses preprocessors with these things called macros all the time. C++, we don't really do it as much, but you'll still see it a lot. So it's kind of weird. We write C++, but we also write C++ preprocessor code, right? Which isn't, right? It's not compiled. It's a way of getting my program set up. But the big thing to know is the preprocessor, what? It strips away your comments and pulls in all your includes into one file, right? So that's the first step, right? It's getting your code closer to a place where it can compile, right? And so the next step would be then to compile it, right? Compilers translate high-level code to assembly. Now, assembly, right, is different depending on which CPU, right, which processor in your computer you have. There's families of CPU, right? And so depending on that, right, it will translate it to what assembly you need. So like in here, when we compile, we're doing them on, right, Pentium or Intel architecture, right? Intel and AMD, they kind of have the same architecture, right? So it compiles to that. And so someone had to write a compiler that takes C++ and puts it into that machine language. But if you're doing it on your phone or you're doing it like on an ARM processor, there's going to be a different compiler that translates it to that CPU's machine language. Does that make sense? So there's a bunch of different ones. The nice thing is that we don't have to write them. They've already been written to us. So we just use them. So we take it from the preprocessor into the compiler. The compiler translates it from C++ high-level code down to what? Assembly. Okay. Now the assembler, which also has to be written for, right, that CPU family, right, takes your source code and creates object code. And it takes your source code, right, like a bunch of move statements, and puts it into binary, right, zeros and ones. The computer's only talking zeros and ones. Right? Usually you get a .o file, right, for object code. And I'll show you today how we can actually create that. Right now I have them being created automatically when you type them in. Right? And then the linker, or the link editor, you'll hear it called both, takes all the O files that you need and creates a single executable. Okay? And what this means is that you can now write files that don't have a main, right? Call it a library file, right? It has a bunch of functions. And you can compile it to object code. Okay? You don't need a main to compile your code. You only need a main if you're trying to create the final executable. Right? You need one main. But what can happen is that you can create lots of object files, and then you can link them all together into one executable file. Right? This is nice because when you get to big projects, right, big programs, right, you're going to have tons of files, and you don't want to just type make and rebuild everything, because that's going to actually take a long time. I know right now it's like, okay, it takes 3 seconds to build my program, right? But I mean, it can take hours to build a program, depending on how many files you have. So you just want to change the ones that got changed.
Is this the same thing as creating a library and creating separate files from one with
Mm-hmm. Yeah, so you create your separate files, then you can do them all into their own object files, and then link them all. Right. So the object file is going to take, or the linker is going to take all your object files. This is where your operating system runtime support comes in as well. Bring all that together into a package, link it, and that's where you get your executable, the thing that can now run, / right, a.out. Does that make sense a little bit? Any other questions there? Do you want to see the development process, what you should have been doing this whole time?
Can you go backwards to the previous process?
You cannot. So can you reverse engineer it? Not well. You can. There are ways to reverse engineer code to like translate from a machine language to assembly, and then try to translate from assembly to some higher level language. But inevitably, it doesn't come out right. You kind of lose all your functions and all your objects, and you just get a big spaghetti of terrible.
That's good.
Right? Yeah, I think that's good. We don't want to go there. So what do? We define the problem to be solved. Right? Who's been doing that? I've been doing that, right? Here's the problem you need to solve for a grade. Right? Step 2, design a solution. That's what you do. Right? Oh, did you know designing a solution is different from actually writing the program that implements the solution? Right? There you go. I just type stuff until it compiles. Right? And then just see what happens, right? But the idea is that you would look at, right, you should high level look at what solution you want to attack, right? Do I need loops? Do I need functions? What do I need? Right? And then start writing the implementation. Right? Then we compile, right? And the compile changes the object code. We link the object code together, and then we test and we debug it. If there's any problems, we go back to maybe our designing a solution, and we do it all over again. Right? We keep doing this until we either get the right answer or we give up. Right? It's kind of interesting. In class, you can just like give up, right? If it was a job and it didn't work, your employer wouldn't be like, oh, that's fine. Right? If you just want to give up, I'll just, pay you a little bit less this month and call it good. No, it doesn't work that way, right? You have to find the solution. In a school setting, I always tell my students, you can do as much as you want or as little as you want in my class. And you can show up as much as you want, or you show up as little as you want in my class, right? But what? Your grade reflects all of that. So right? You're paying to be here, or someone's paying for you to be here. Could be either of those things, right? So you can show up or not show up, but you'll get, right? You'll learn in relation to that, and you'll get a grade in relation to that.
This on the test.
No, this is life advice. So we're stepping outside of like C++ land, right? And this is just advice for life, like, right? Hopefully you're in school because you have some goal that you're trying to accomplish, whatever that goal might be, right? So I try to remind students at some point that, like, you know, this is class and it's school, and school's not real life in a sense, right? It doesn't look the same as the business world. And so at some point you have to make the jump from learning in a classroom environment to then like having a real job where, and a lot of you already have real jobs, but having a job where, you know, this is your full-time job, and, you know, you got to be at work on time, and you got to actually do your work. People are counting on you to do stuff, all that kind of stuff. At some point you have to make that jump. But this class is not that jump, so right now you can still be students. So that's the process. How do I do it? Well, G++ is my magical program that not only is a compiler, but it has an assembler and a linker built into it as well. It's the suite of tools, basically, that can compile our code and get it executed. So it does the C++ preprocessing for you. It does the linking and the compilation for you. All right, and so G++ is a compiler plus more. Right? And so let's look a little bit how we could, at the command line, run G++ commands. So a lot of programs that run like in a Linux environment, programs that run on the command line, they are a program, and then they also have a lot of flags associated with them. And flags are basically ways of running your program and changing it slightly. That is where like a dash something or a dash dash something, that's where these things come in. So let's look at some of the common flags. All right. -O allows you to name your executable. So -O says, what do I want my output file to be, right? So that's what the O stands for. Okay, right now I have it set up, right? Does anyone ever look when you type make? Do you ever look what the next line of code is? Or the next line in your thing? Like, no, I just look to see if it works or not. The next line says G++, and then it has a bunch of dashes. Okay, -O is your output file. What do you want your executable to be named? If you don't do that, you get a.out. Or you get a.exe if you're on Windows, because Windows likes to be different. Okay. But -O lets you name what your file is going to be. So if I do this, G++ -O main.cpp, right? My executable is going to be named what? Main. What am I compiling? Main.cpp. Right, it's going to compile the CPP file. -C compiles into object code, right? So it does compiling, but not assembly, right? So you can actually do that. You can compile to object code one file. You can code, right, or compile to object code another file. You get two object files, and then you can link them together. And I'll show you how to link them. Right? -G turns on debugging, which we'll get into debugging later because you're going to need it this semester. Look at all these fun things. -wall, right? It's actually -warnings all. But warnings all isn't all the warnings, so then we can actually add extra warnings. And then we can add pedantic, does even more warnings. And error, that's a flag that I've actually turned off. I used to use it, but I don't anymore. It treats warnings as errors and your code won't compile. For us though, when we're writing our code, sometimes we want to write one function. We don't really want to deal with the other ones. So we're going to get warnings about like they don't return values or that kind of stuff. We still want it to compile. Right? But this is how I treat your labs and your assignments, right? So I don't have it turned on, but this is how I treat them, right? If you get warnings, you need to fix those warnings when you turn them in. Because warnings are really logic errors. We need them fixed, right, before we really have our full programs. That make sense? So they're all about, right, logic errors. So you can do, right, G++ and then all that fun stuff, and then the file or files that you want to compile. And then you can combine. Look how ugly and long it gets, right? Compile to a file named main, have debugging on, have all these warnings on. What am I compiling? Main.cpp. If that works, I get an executable called main. I can run it with just ./main. that make sense? So what is G++ hello.cpp? What does that do?
Just compiles it.
Compiles that file, right? Makes an executable called a.out.
Out.
Right? It can have logic errors. There's no warnings turned on by default. Right? What does this do? Compile to a file named hello. How many files?
2.
2 files. Right, so those 2 files are going to be compiled together to create one executable called hello. Does that make sense? If you want to compile to object code, you do -c. So then you get hello.o and you get other functions.o. And then later on, you can put the object files together to create one. Once again, we do this more when we have so many files. I don't want to compile 8 files. I only make changes in 1 file. So recompile that file and then link them all together. Okay, it's going to save you a lot of time. Okay. But what are some problems with G++? Why, right? I've talked about G++, but what do you guys type? You type make, right? So why is that? Well, that was a lot to type, right? G++, -o this, -c, -g, -w all, -w extra, right? It's a lot of stuff to type. So sometimes we type it wrong, right? We also have to manually keep track of which files change, so I know that what thing do I need to recompile. I just have to keep track of that. We also need to keep track of dependencies on other files. Now what that means is that my main file might depend on this other functions file, and that other functions file might depend on this other file, right? So if I make a change on the top, I have to make all the changes down below too, right? Those changes need to propagate down. So I also have to keep track of my dependencies. And so a utility, another program called make, kind of handles these things. And make sure that I don't have to type as much stuff. It keeps track of which files have changed, and it keeps track of my dependencies. All those things happen in make. And so instead of typing G++, -o, -whatever, blah, 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 you just type what? Make. By setting up a make file and letting it automate the process. Video. We're going to watch a video? That's not true. Okay. Yeah, there's some history to make. Yay, it's old. All right. So how does it work? It reads a file, right, which is called a make file, go figure, right? So it reads a make file, right? And that make file has rules for building your target, meaning building your program. Right? If that target is based on some file, which they usually are, then it's going to build that file. Now, if that file depends on another file, then it's going to build that one as well. So it's going to propagate down and do all the building that it needs to do. So it's going to work backwards through the chain of dependencies. So we're going to look at that here in a second. Right. So we're going to pretend like I have 2 files, right? Main.cpp, factorial.cpp, and hello. And there are some dependencies here. So you can think of it like this. We have a main file, right? Main.cpp, right? And it depends on factorial.cpp, right? And it depends on hello.cpp. And what I really mean on depends is that in here, it has what? Pound include, right? Factorial. Okay. So inside of that file, it has includes for these other things, right? That's really how those dependencies are set up. Right? And that's what that says. And so here's some ugly code. It looks like it because we don't understand it yet. But here's makefile code that we would write. That way I can just type make every time. All right. So let's break it down a little bit, and then we'll get into our lab today. So these things before the colons, these are my targets. All right. So target 1's called hello. Target 2's main.o. Target 3's factorial.o. Hello.o. And then another target called clean. Okay. When you type make, it always runs the first target. So when you type make, it always runs the first target. Okay. The thing after the colon are the dependencies. So in order to make main, right, and the main is called hello, in order to make that, I need a file called main.o. Right? In order to make my program, I need main.o. And if I have main.o, I can just g++ main.o and output it into a file named what? Hello, right? So look at this as its own command. When I type make, it's going to run this command. Now what happens if main.o doesn't exist?
It'll make it.
It'll make it. And it'll make it because I have a target named main.o that says what to do if I don't have main.o. Okay? That target says to make main.o, I need main.cpp. But because main.cpp depends on factorial and hello, I also need factorial.o, the compiled version of it. And I need hello.o, the compiled version of it. Does that make sense? And if I have that, I can compile to my object code main.cpp, which will create what? Main.o. If I don't have factorial.o, remember it depends on that. If I don't have that, well, there's a factorial.o depends on factorial.cpp, and we can compile it. Hello.o depends on hello.cpp, and we can compile it. And then almost every make file has a make clean. Make clean will remove kind of your executables. Because while the programs are cool and the object code's cool, right? We really care about my source code. So if I want to get rid of all the stuff that I've compiled, I type make clean. And this will remove, the star.o says remove all of the .o files and remove my executable, because my executable is called what? So let's see what that will do for me. Everything. Good. We're going to look at make file real quick. Right, so that's that same make file that we had on the board. Right. So if I just type make, right? If I type make, it's going to compile hello, right? Based on factorial and that. So I do an ls again, right? I do have what? Factorial.cpp, main.cpp, hello.cpp, and I have my make file. So if I just type make, if I type make, right? Notice, right? What does make show? It shows all the commands that it's running. Right, everyone see that? It shows all the commands that it's trying to run. Right? Notice all the commands are G++ commands, because G++ is my what? Compiler. Now if we go back to that make file, right? Do note that when I type make, it's supposed to run the first target, which is hello, which is what? G++ main.o. And we go with that. If we look at what it ran, right? Did it run G++ main.o? Not first. Where did it run it? Ran it last. Why did it run it last?
Because it didn't have it.
Because it didn't have it, and it didn't have the things that it depended on. So it actually, notice, it went reverse order, down the dependency, really up, trying to figure out what do I need to do in order to build this thing. Right? It also made some files like hello.o and main.o, right? Which is just binary, right? It's always fun to look at binary files. Right? See it anyways? Yeah. Isn't that great? Because it's just, remember, it's just machine language, so it's zeros and ones. When you try to look at it in a text editor, it's trying to take those zeros and ones and interpret them into character, which is why it always looks like garbage. Don't look at object files. They're ugly. Now, if I, let's say, I'm going to say make clean. If I make factorial.o, right, notice it'll do that. And if I make hello.o, I'll make that. Oh, right now I make hello.o. And then I say make main.o. Right. And now, if I just say make, you'll notice that, did it run all 4 commands? No, right? Because the dependencies existed already. And then the cool thing about make is that I could go in and I could All right, let's actually, that should be right here. Turn over that factorial. All right, nothing in X. All right, so I changed the file, and it should. All right, notice I changed factorial, and I notice it had to what recreate the factorial object file, which main.o depended on it, so it recreated the main.o file, and then built it all. So one cool thing that make does is that it remembers which files have changed and which things need to update. Right. Sometimes you type make and it says like, what does it say? Nothing has changed. Let's see. We need it right here. Right? So when I type make, right, it says hello is up to date. Anyone have done that before?
Yeah.
Right. So you type this because you never made any more changes than it compiled the last time, right? Including if there were warnings. So if you want to recompile and it keeps saying that, right, it's up to date, that's where make clean comes in, because make clean gets rid of everything that you built, which allows you to then remake it. So if you ever have that, right, it's up to date and you want to recompile, say make clean, and then just type it. Does that make a little bit of sense? I think it's good for us to know what's going on behind the scenes. You don't even know it intimately, but just a little bit, like typing make does something, right? Typing G++ does something as well. Those things are important, right? And at some point you'll have to write them yourself, but for now I've kind of given you what you know. Questions there? All right, let's look at our lab. There's more in that in the slides, but you don't need it. So
I don't need it.
You go look at it on your own time. How's that sound? Hey, that sounds wonderful. So let's look at today's lab. Today's lab, right?
We're coding all of it.
You've done all of it. Yay for you. Right? Notice the function prototype's the one thing that goes up. I'll help you code the first one. Right? So the function name's hello, so what am I going to type? Hello. You notice that the H is capital, right? So your also needs to be what? Capital. Does that have any parameters? Notice it says none, so I just open and close paren. Right? And then its return type is what? Void, so I put it at the beginning. Right?
I see.
So there's your function prototype for what? For that. Now you are going to copy that and put it below main, right? Change the semicolon to curlies, and then do what it says. In this case, what? Say hello world to std out. What is std out? Cout, right? So std out standard output. That's where cout writes.
Oh.
Right? You'll notice that it says what? No new line character after. So don't do an indel, don't do a \n, or you will fail the test. Because I'm reading your cout and making sure that it says hello world, capital H, lowercase w, exclamation point, no what? No new line. Right? We're just saying that because that's one of the, I guess, detriments to unit testing is that there's no like close enough. Right? It's either exact or it's not. Like it's either pass or fail. Zeros or ones, that's what I work with here, right? Zeros and ones.
Yeah, true or false.
True or false. It works or it doesn't. Is that how I should grade the class too? Either
you pass
you
or
get
you
it
don't.
right or you get no points. So you either get 100 or you get a 0. Or we just work on ones and zeros, right? That'd be rough.
A class where you only do 1 and 0. It's like you did this assignment, you get 1.
I think the odds are most people would fail. Right? You missed that, right? Your comment wasn't perfect.
This lab 6 or lab 5?
You get
This is
-1.
lab 6.
Can you post lab 6? Because I tried pulling it and it says it was up to date and I
It's
didn't
all
see
there.
it.
Get pull class master.
Oh.
Get pull class master. We'll
Okay.
pull it in. Yeah, so I've added I think lab 6, 7, 8, 9, and 10. Assignment 2 is on there as well. Another function named print message. Notice this time it has a parameter. It's const call by reference. No default arguments. It's what?
There we go.
I was gonna ask that you mentioned assignment 2. Is assignment 1 due at the end of the week?
Assignment 1's due at the end of the week. I try to give you at least 2 weeks ahead of time what's happening in the class. So assignment 2's out there, but there's no expectation to even look at it until next week. But I always try to get us 2 weeks ahead. Assignment 2 will take us to the first test. So that's an assignment.
Yay.
Yeah. This is week 4. I think our test is in week 6 or something.
So assignment 1 is due Thursday?
Assignment 1 is due Thursday and today. Right? So if you haven't started on it, I highly recommend that you started on it last week or the week before. So if you get a time machine, that might help you out. But otherwise, right, you're going to want to work on it, and you're going to want to work on it somewhat in class, right? So I can give you help on it, so you're not stuck at home for hours. Yeah, it does run the fun, right? You're like, I like it a lot more programming when I can just write that other people. This class was so hard, I sat for 3 hours and it was a stupid semicolon on 1 and 3. It's all right. It's okay. It's all part of it. All right, question on lab 6.
So lab 6, we're just writing functions?
So you're writing the declarations, but then you're also going to write the definitions.
Yeah, and that's it?
And that's it.
Okay.
And the functions aren't necessarily too terrible. Yeah.
It's like what we've been doing.
We've been doing just more of the same, rinse and repeat.
Just now we don't have the declaration. We have to make that ourselves.
Right.
Well, we have the comments, but
Yeah. Because I've been giving you all the declarations, and I think it's good for us to practice like to do it ourselves.
next thing you know, it's just going to be an empty file, and we got to start from there.
Exactly.
Which we're going to do.
Which we're going to get to, yeah. That's coming. That's coming. All right, great. I'll get the sign sheet, so just make sure you sign that too before you leave today.
You're going to be working on lab 6? Because that doesn't seem that bad. Lab 6 is pretty easy. And then once I'm done with that, I can go back to lab 5 and work on the other functions I didn't do. And then I'm going to go on assignment 1 and start testing. Because I have the definitions, or declarations. And then I have to start coding stuff.
So commit it, push it, and then submit it to okay. I got a sign.
Is it just one? change this, this one, the next time I get to one make, say like I is less than size, I is less than values, size. I is less than size times one. I thought I would need it.
Oh, wait. You're comparing. So just, you don't need this. You're actually comparing the value that's at that location.
It doesn't matter what the names are, do they? For these functions, right? When it says call by reference, you can just call them whatever you want, right? Because that's the name inside the function. Because it doesn't matter what it's called; it's just going in, and then I have to reference them in the definition. Like I'll just name it whatever I want, and then I have to make it call by reference. So does that mean the ampersand goes before or after? Is call by reference the ampersand is before the name? Like it goes int ampersand name, or is it int name ampersand? Is it before? Yeah, I'll try that.
I think on lab 5 have the. Yeah, you don't need the. No way. This doesn't have any factor. You need this, but this is like then find the outside of your board. Because it's basically tacking on the last.
It's not as good as this.
You know why? If you run the last number go through this,
Why don't you do like I say, string your.
Have you noticed that whenever I show,
Yeah, you talk like that. Yeah.
I don't know if it is. I love that
Use QQ as your desktop, leave it on, and then use it on your iPad or something. Figure out how to use the mouse.
Oh, no, they added it. Yeah, it's sports.
that one is
What I was gonna say is your team viewer on Windows, through a stream machine.
like I ordered.
This is only when I work on stuff.
Work on value, pass value.
And what's that?
What is it called?
It's a speed word. It just has a
Actually, should be really strong. Actually, so because you're checking on the very last.
It's like a small widget, but it's still kind of a mouse trick.
What the hell?
It's like it's probably like this
It's possible you can't use I outside of that. You can use I outside of that. But so it shows you, so
Chinese things are.
you're actually pretty close. So I believe that what has to do with the ID is because it's, I believe it's more than one space per person. It's picking up.
So should be like,
Oh, yeah, I forgot about I equals 1. Because so basically you want to start off with 1 instead of 0. Because right now you're starting with 0.
Let's see if copy one. Copy first.
So.
Did you just start last slide? Did you have one last slide yet? No.
Oh, okay. So you're.
What is all this? Yeah, I have markers.
So you need to be putting that value 1 or 4. So since if you're at value 1,
Is that how the change do?
yeah, what you're doing is taking
So.
I'm sorry, because
Jump from knowing one piece to another. Yeah, I was.
When you're doing plans.
This week, I'm not gonna be here next week. Next week, it's the Lord. Next week, it's the Lord. But I'll still be here Monday, Wednesday. But I'm not going to physically. It's I'm going to a conference for my major. To verify our.
Okay.
That's right. I don't
So,
remember.
on is being compared to the value of the biggest.
Okay, new labs.
See what I'm saying? So that's not the actual size, that's the value stored at that.
The joke is
like the biggest.
why don't you just watch Rage? It's even better.
It's more.
I want to show you the scene. It's more political.
Because there are changes that you've made. Okay, what you just
You were pulling a random value off of the array, like the size was I remember looking out, and it was only going one past it, you know, it could be any value, it could be going forever past it. I got more numbers.
Oh, my signature.
You can't go up. Yeah, now you're
like what you want to do.
when I look at this value, so it's going to be similar to what you just did. You're going to want to plug it. Basically, you're going to go through each individual value and get each element.
Oh no.
Oh, I get
And then a similar formula to do that. And then now what you're going to do is you're going to compare it to this number that he's passing in.
Right?
It's a badge, like it says, do this together. It says, change majors. Oh. I'm not that.
I just haven't done anything.
Alright. Accept the invitation. Now you're in. Yeah, that's weird. It should have, that was a while ago, like that was the first week fast. Right, there you go. Try that. Right. Yep. So it's based on what you think it's supposed to be, you know what I mean? You're on
Yes, correct.
Alright, so that, so all that means is
Break everything. What? No. Oh my I wish I could say that.
do that and then you should go to
Oh, you're really, I like bullet hint. Are you gonna give me a photo that I want to do that I
Yeah, I'm just.
Okay. No, I
didn't forget about you guys. Trying to
It just sucks.
When I started, first, after I second, third. Knowledge.
More like the one. That's why I'm
so you can do the check, you can do the
That's one of the things.
but then keep freaking out for
Did it already come from back here?
It basically means it's not.
It just works.
Is that hearing command? I have
More like
You know what? You should have. Well,
you know what? I have figured out how to use GitHub and Visual Studio.
oh, nice. That's nice. April's teaching CSCI 20 in C#, so she might be using Visual Studio.
No, she's not. She's still using that. My roommate's taking the class.
With the C#.
Yeah.
See, there I might actually like be like, okay, great. We'll probably do Visual Studio too.
Oh,
Something might
you
be.
should use Enterprise for live shares. So nice. She can like plagiarize.
That's it is equivalent with single as assignment. Yeah.
He said she has something to code me.
Oh.
Yeah, so two things.
Well, first of all, you know what? It's probably because you didn't have that or it's bad.
Oh, no, I don't.
It's because you were distracted by everyone else. Hey, when
Oh, yes, it is the else. Because it's, the else is inside of this for state. So when it's forked over, you don't have a return.
Oh, that thing.
The return process inside of it. I don't know, you know what I'm saying? It's inside of the for. That is right there. You don't have a return. I would do that.
Yeah, you're
So basically, if I just have it, it's not equal to.
Correct. Basically, it'll be out the second half.
Yeah, that's not cool. You like Trump and reading lots of fucking jealous.
So there's an
Basically, the for, which is never you still need to.
It actually made it really confusing. If you want to do
Like the LCD out, that means yeah, right?
Serial?
That is very strange.
Oh, yeah, for dinner. Two fish fillets. That's what you told me. The chef.
The documentation is good, which
It was bread, that's just water. Oh, okay.
If online parameters and follow reference, they can't all have the same name. They still follow that same.
They can't have the same name in different functions. Just they all can't have the same number. Two parameters in the same function can't. But each function can be used.
Even if they're by reference?
Yeah. Because they're still local to their function.
Okay. To be fair, he doesn't. Nice. I'm gonna look at the comments. It's not gonna work. Stupid. Thanks. Yeah, that's somebody else knows.
No,
Yeah, he was in like class. Yeah, he was in my programming in my math class. Yeah, he was dumb as a post. He would make fun of me. He's friends. He's friends.
Did the sign sheet get stuck somewhere? I don't want to say it to you, but look next to you. There's a paper there. Keep it moving.
Does anyone else need a sign-in sheet?
That's just what it was. But it was good.
Okay, so yeah, that's true. So it should be like that. So the trick to it basically is that so there's a reference, right? So you're not returning it, you're just changing it to a reference. So basically change it to somewhere else or not. And once you just do that, you see that returning false. You're also setting the so it's basically if it's going to pass, otherwise it's not true.
I got a motorcycle, it's like, quarter mile, it's like 55, 60 miles off road. Yeah. 55. I have that trail back at the time. I ate shit, so. Only 20 miles an hour. And it was cool. Have you ever put a train? Wow. Scanning. Also. Yes, sir. Once we get through, as soon as you set it. What's your name? Yeah, then we'll start going on with it? Yeah. But like, usually the first couple will all be the same, so you can get 1, 2, you can do them, and then figure out, oh, it only takes me this much.
Weird problems happening. Okay. First of all, those now, I'm not good with I don't know what's happening.
Interesting.
typing here, it's just press control like my press control V, it did something. I usually have to press control Z twice to get back to where I was. I don't know what's causing it.
Yeah, I don't know why she's so. How many years do you have to do this?
Maybe try it out. What happens is that, oh yeah.
Wow.
Is this right? So up here is running the generation. So just this. You're going just like in that last class. Take that and put it down here. Down here. You're trying right up there. Is it the oak? The breath. We'll do it. So this piece will write the actual code in combination. Oh, my kids went forward and work out. Copy and paste that below. And there's part inside there. I think probably what we're doing here, so, and it's H, that's where you'll do the prototypes. So the prototypes will be on there. So what'll happen is that this thing here, actually is what goes. This should be
And then
so this is actually here is where you write. Okay. Keep it going. You don't get I did this one.
I was like, oh, okay, well. Still has a probably good solution. But like, the reason is like, it's really frozen. How much chemical in that? It's just taking care of it, you know? So, if it doesn't pass the test, the code is really slowing down. Like, the code is really issues. You
can look through it.
Then it's frustrating, you know, like, then it gets like, that's so bad.
Yeah.
But I have to do something, right? You can get close and then you can make it close.
You don't have to. You don't need the string. So this says the character at that location becomes there.
Oh, so it's gonna be too easy.
Yeah, so you just return proof. You don't need throw as well. But you don't need throw.
Hey, thanks. It's a typo, it's just like, I should just like yell out this whole thing.
I mean, you read
I was looking at
you're
like,
wait.
Matt Message. I'm like, Message.
It won't call the function. Why won't it call the function? Like this.
This one?
Yeah.
Can't you just?
Well, get stats needs more, right? It wants to know how many upper, how many lower, and then also how many. So, remember, functions don't return one value.
I was thinking this was were needed for my counting process.
Like, I don't need those. No, start them at 0 and then
I see. If it finds an upper.
yeah, then add one.
False if it turns out that this environment is true. Otherwise, we have to. So I take this out? No, it's an addition to that. That part is figuring out when you're actually returning and then changing the global value as well. So. It's just I know, it's put it this way, the only thing is, you're only returning one at that value, right? You can't return a second thing. What you can do is change the global value. And that's what you're doing. You're changing this global value of error, which you're holding. The false of this, if you can operate, obviously it's error is false. There's nothing. If this doesn't operate, then it's false. But if the error is true, and then it returns 0. So you basically just have to set it, since it was passed in by reference and it's global, and when you just set it like this, you're changing it from I know it's kind of a weird concept, but it's how you can make one function change, like return multiple values. So you just can't just add an additional. I don't think about it too, because. function, forget stats, you need to zero out those two inputs.
Because otherwise, because remember, they're going to be passed in. You can't trust the user to pass in zeros, right? You want it, we're going to count those on start at zero.
Well, the only thing that messes with me is that by reference. I don't know. I mean,
You still said zero.
I'm assuming they're not being used anywhere else, I guess, right?
Right. So you got 7 0 and start counting.
Otherwise, I would worry about that. Like if other functions are also calling that same reference. Then I would.
It's somewhere, and it just dropped it off, and so it's like, you know, her climate or something, and I'll be like, why is that here?
Probably just create out, it's like.
Right, at least it's in a comment that it
It acts like I'm pressing a couple of keys and I don't know what they are. I have to press control.
sometimes you're having.
But I just do the name.
Oh, that's so cool, fun.
No, I know, it's sucking.
What's that yellow bar to the left that's like, I think it's supposed to highlight code blocks?
On the, in the editor?
Yeah, I think that's what's doing it. Now I have a yellow bar right where I was typing.
I think the yellow bar just tells you what's changed and what happened.
This thing here.
Yeah.
Because that's new since it adjusted it, maybe go to top and came back down without pressing Control Z. Now that's it. So I think that's the feature you did.
Yeah, no, yeah, you're right. It was kind of like a block.
Yeah. This whole thing is one big block. Okay.
The feature gone wrong, right?
Can I just quick increment like val to plus?
Yeah. I don't need you. Yeah, if it's right, yeah, val plus.
Yeah.
Like, what happens if you try to shoot upper a letter that's already uppercase?
Because it stays uppercase.
It's
So you don't have to check it. You don't have to check it. It's operator call good. And if you uppercase the pound sign, it stays pound sign. Or exclamation point. It's not gonna pass.
Lab 6 focus, could I like use two upper and then count how many times?
So the problem is.
I got the thing to compile.
This number tells you. Yeah. But don't check it to true, just say if is upper.
Yeah.
Also, the issue is that's only going to run about once. Index is going to change. It's going to index is just where you're pointing here.
Alright, so too few arguments.
I had an issue with 2 little arguments. Like I accidentally forgot the arguments. So when you try to make this one of yours,
So if your index was equal to the size, you're only looking at that very last digit, and that's it. It'll never be straight. Basically, as long as the size is not, the index is not equal to the size, it'll be right. You want your index to be equal to or less than
Expected primary expression.
But also,
Constants for the declaration.
Basically, because it's a negative one.
Just like standardized.
This is your greater than or equal to 1.
It's not declared.
Because you want your size
Go to the
function to be a single.
The const string message.
Index is less than.
Just okay. Go to the logic underneath me. Right. Oh, that's the logic right there, huh? You don't need K in front of it because you never defined it with the letter K. You probably should do that. Because it's a constant, it should have a K in front of it. Yeah, so put a K there. Go back up here. Put a K right there. Wait.
Zero.
Yeah. I'll try that.
Oh, value at.
I don't know.
And
It was not declared as so an input comes in, and the input is a reference to K message. Let's see what I do. Should probably make my constants K.
I mean, I can't see why it's messing with you, but I would get rid of that else. I don't know why you're messing with you, but that's the only thing. Yeah, typically that read else is, I guess that else is. Outside the border. So you're still coming down there. Your size is greater than or equal to 1, right? Index is greater than size. You just size or just greater than size? Yeah. It's greater. Or I mean, no, less than size. Sorry. And it's greater than or equal to 0? Yeah. Your index can equal 0. 0 placeholder. Yeah, so you're going around to all faster on your own side.
I was looking in here for the longest time thinking there's something in here.
Yeah, I don't know if your house actually was messing with you, probably wasn't. Yeah, you just have to logically think about your checks.
Yeah,
It's not super easy. I'm not saying it's just simple.
If the letter isn't uppercase, is it lowercase? Or could it be something else?
I just compared it to itself. Its 2-upper version of itself. So if you compare something to its 2-upper version of itself, that's how you know it's uppercase.
Makes sense, I guess. What if it was like?
No, string.
Otherwise, I don't know. You'd have to know the ASCII numbers.
Yes.
You know what I mean?
String
That sounds like
first,
trash.
then it's const, because you're mapping the string plus.
That's gotta be right.
Okay, go back to the logic. C plus. It takes an input. So if you go back up to the function declaration, copy that. And go back down. Now remove that entire line right there. Or, before the curly brace, because you already have that in place. No, I mean, so, where it says void print message, highlight that all the way up to the other parentheses, and then paste. Now do it. Oh no. Function unit.
I think it's because I don't have these other ones for that.
Okay, so basically, so what I did here, right, is, so it accepts an input, right, which is the constant K message. You just output it. And that's what I did. I forgot to put this here, because it needs input. So those two are correct. What you should do is you should define all these.
Yeah.
And see if it compiles.
On the, this is a very good question when we had it. Are we, let's take this I mean, basically, considering this, and this is right? But I realize that there's cases.
Right. Just remember that every string knows how big it is. So you don't have to count it. Remember? You have a dot, something function.
Yeah, that's nice.
So just return that.
Well, that's what I was planning on. I was just worried about the other two, but.
But the other two were fine.
I was going to generate the value, the second value by subtracting the first value.
As long as you check like is alpha and is digit. We have to work on it.
What about those?
Yeah. Wait. That's what you should use.
That's a check you can use? I was just thinking about
Is alpha. Yeah, you don't have to like run through the gambit of like allowable characters. Is alpha tells you if it's alphabetic, and is digit tells you if it's a number that's a character.
Okay. And then returns true or false. So you can use that as a single argument.
So easy.
Is alpha, right, your string dot at I or whatever you're doing.
And technically, two upper and two lower is doing the same thing, right?
But they're converting.
Right.
So they don't know what is converting.
If you're comparing it to itself, but if you go two upper, it's not going to equal true unless
But if
the letter to begin with, right?
Right. But if it was like a pound sign, your upper it's still going to be a pound sign.
Oh, I was assuming it turned into magic or something.
Yeah, right.
It's all magic.
What's an uppercase pound sign look like? It's a hashtag, right? That's what it
I figured just adding a number to it, to the ASCII number and make it upper, if it adds that same number.
No, yeah, it's smart enough. It won't uppercase stuff that can't be uppercase. What did you
Yay! I did it. Crap.
Okay.
Luke is always one step ahead in these unit tests.
Yes. I'm number 2 steps ahead. Just,
Like I try something and it just says no, that doesn't work.
Oh yeah, I was last year's approach.
Giving you enough.
I don't think that's what you do. You did just fine. That's because there's a little bit more interpretation right now. It's like, no, you must do it this way or you fail.
I'm back in my hours of change.
All right, enjoy the.
It's never to be enjoyed.
Brutal.
I thought I had a bad boy.
Physics, man, get anyone a bad mood.
It was cold.
In the in sum function of lab 5, are you adding 2 numbers or multiple? Like more than 2?
More than 2.
You're adding all the numbers in the array.
It's in array.
Okay.
All the numbers in the array.
I have an idea of how to do that, then that idea is kind of shot since it only uses 2 numbers.
Yeah, so you have to think about, you're gonna, the hint I'll give you is that you need a running sum. You need some bucket that starts at 0, and every time you loop, you're gonna add to that bucket.
Oh, that's what I'm missing.
Okay.
I didn't start at 0 on that
Can that be
one.
global?
No, please, nothing can be global.
I didn't set it equal to 0. That's my mistake.
I just want to give everything X and just put a comment next to it.
Right, call good. At the very beginning, they global use that N, A through Z, right? And then.
Yeah, I hover over it. I hover above it. It's got just a comment above it, highlighted on the mouse cursor. I hover over it long enough. Visual Studio
Damn it.
doesn't. So that's how I actually started with Python. They were all named similar names.
Right.
Find larger
And I used
if
Visual
the
Studio.
value.
Oh, for lab 6?
Yeah,
Yeah, I have a problem with that.
yeah. If the values are equal to each other, we can't return both of them, right?
And then
So,
and then I.
See, my only issue is, let me run that test. Okay, so basically what my logic says is, let's just say the first one is -1 and it's comparing it with 1, right? And it says, is -1 less than 1? And it says, well, yeah. And then it stores that. And then, wait a second. How did I pass that? Oh, okay. So it changes it. Right now? I didn't write that much code. And mine kind of works. Kind of. Just that when he threw a negative in there, it kind of died.
Didn't give me any errors.
Hold on.
I said this because I'm going on building spelled out.
So let's look at your logic here. Made a temporary number. K value 1. Type number 2 is K value 2. If it is greater than the second one, you return the first one. If it's less than the second one, return the second one. Or else it's number 1 is number 2. Yeah, I see what you mean there, but what if I made this second value -1? What if I made this -1? What would happen?
Well, is it larger or bigger than 1?
It would say, well, number 1 is 1, right? 1 is greater than -1, so that's right. And then it'll say, is 1 less than -1? No?
So
It would just output -1. But well, actually, it would just run this, right?
well, this is true.
If that was true, right? Because
Yeah, 1 is bigger than -1, so that would be true.
oh, and what if this was -1?
And that wouldn't be true, and -1 would be.
Less than 1. Oh, I see. That's what I'm missing. I'm missing another if statement. Because I have 1, and then I need to do another one to check if it's the other way. So I'll do that.
Yeah, so the unit test, if you're saying make unit test, I believe.
Yeah, I see what you're saying. I just have to figure out because I have a temporary integer storing the value that needs to be returned, and I have one if statement checking the first value with the second, and if it says the second one is greater, then it does that. Then I have to do another one where if the
So if index is const called by reference, you would write like this. You would say
oh, okay. Hold on.
That's constant called by reference. Constant variable, and by reference is the name. Like that. This doesn't look like that too.
That one?
This one just doesn't.
Oh, yeah. That's good idea.
Yeah, you might have to change it above too, right? Because it's not in such places. Yeah. Yeah, so you could do it that way. Really, the way that you should do it is true to length. Remember, whatever's in the if statement is going to evaluate as true or false. Not zero. Here, I mean, you know, these not negative size. Yeah, equals true. It gives you a non-zero value. Yeah, that value. And then make these supposed to be color in between things and make this. Somewhere.
For assignment one,
Yeah.
for assignment one, if you do the or whatever, what if you make the test file different things than we named ours? Does it work? Or does
If you named your functions different than what I said they're supposed to be named, it's not.
oh, no, I did that the same. Then what if you said like max, int max or something?
My test will test based on what the PDS says. If you wrote it to what I said, it's really fine.
So basically, as long as your front half and your variables inside, that's all he's really checking. Everything else below
What you
that.
name in your function, I
Yeah.
said that. Because the function will take input, so I'll pass an input, and then I'll expect them to produce a value. That's all I test. What you do inside of your black box